Good evening, everyone. Thanks for coming on a Wednesday evening. So I'm going to continue from where Max left. He showed a wonderful tool and very nice applications of agents. So I'm going to continue to talk about agents, dial it down a little bit, and talk about the need for agents, and perhaps use a little bit of coding to showcase an agent to you guys. Right? So I had the training vertical of Analytics Vidhya. I look at the development of courses. Analytics Vidhya is a edtech platform focused on generative AI, data science, analytics. We have a lot of content on these topics, around 200 plus hours of content on generative AI topics and 500 hours plus content on data science topics. What sets us apart is that in our edtech platform, we offer one-on-one mentorships to learners, right? So we do corporate trainings. We have a very humble beginning. We started as a blog, and through that blog now we have a community of 4 million strong over there. Just a side note, Vidya in Hindi means knowledge, so it's like literally analytics knowledge is what this company means, right? So coming back to the topic on why do we need agents to empower LLMs, right? So 2 years back it seemed, why do we need to really empower the already powerful LLMs, right? But seems like they do need some empowering. So we know that large language models conventionally, they have been trained on large amount of data, and then they reproduce the text based on the query that we have, right? So if we want them to create a proposal, if we want them to write an email, they use their existing knowledge to give us information. So if we have a query related to, what does NVIDIA do? It would already have trained on that data, and it would give us an informative reply on what NVIDIA does. But if we ask it, what is the stock price of NVIDIA, and perhaps for the last 10 days, that's where your large language models would fall apart, right? So ChatGPT is not just an LLM, it is also powered by a lot of agents. But this is a query that I typed in this morning. And the one on the right is the result that I got from Yahoo Finance. And the one on the left is what I got from ChatGPT. Bear in mind, ChatGPT does give the right answer sometimes, but not very reliably. So for example, the price, if you look at the closing price, it is indeed the correct one, but ChatGPT is giving the wrong date for it. Right? In fact, let's just try it out. All right, let's see. Okay, so this time I think it's doing a bit worse. So July 23, 122.89, that's the closing price. Let's check. I have Yahoo Finance. No, so 122.59 is the closing price, and that's saying 122.89 and does not give today's price as well. Right, so this is where LLMs can help us, right, to get that context which is not available with the large language models, right? In this case, the stock price. So some of the use cases that I think Max showed us, those are also very relevant. For example, accessing your calendar is what Max showed us, right? So accessing your calendars, perhaps looking at the meetings that you have upcoming, looking at the profile of those people, creating meeting notes for you beforehand. That's an area where LLMs would need a context, and then humanize the output for yourself. Similarly, prioritizing emails is another example that Max showed, responding to customer queries, and finally, what we were talking about right now, stock. Right, so let's look at the same query on a small agent that we have built, and let's see what is the response over there. So I'm going to head to a Jupyter notebook where we have this agent which can fetch data from Alpha Vantage, which is a popular tool to get stock data. And let's see if this works well. All right, so we are getting today's price as well. And let's see, 114.25. There is a drop in NVIDIA's price today. 114.25 is what Yahoo Finance is also saying. And we get the prices, not just the closing prices, but we get the open, high, low, close as well. Right, so let's further ask it, okay, what was the highest traded price in the last 15 days? Right, so let's see whether the agent is smart enough to tell us that. All right, so we get two outputs. One, we get to see which tool was being used by this agent. So there's a particular tool that we developed called Get Stock Price. Second, it says that the last 15 days highest price was 136.15. So interestingly, it looked at the data, realized that it has to look at the high price, right? And then gave us 136.15 from the last 15 days, right? So this is where the combination of agents and LLMs comes into play, right? LLM acted as a reasoning agent to identify which is the tool that we use, and then pass the information from what the agent collected over here, right? So that's what agents can do. Agents can get relevant information which was not utilized by the LLMs during the training phase, and then our LLMs can act as reasoning agents, one, to choose the tools, and then to make decisions based on that. In fact, let's try one more query. Over here, what are LLM agents? Let's see if any tools are being used in this scenario. Oh, so in this case, none of the tools are being used. So LLM is directly giving us this outputs on what LLM agents are. Right, so this is where LLM takes a call on whether to use a tool or not, and then accordingly give us an output. So this is a very typical workflow of a very simple agent. Think about it as a one single tool. When we ask it a common query like tell me about NVIDIA or what are LLM agents, the LLM directly gives us the response based on its knowledge, right? Whereas if we ask it a more sophisticated reply, which relies on current data, in this case, on the stock price for the last 10 days, the LLM looks at the different tools that it has access to, identifies the right tool, takes the action on that tool, call back the LLM so that we can get a humanized output to eventually give us a response. And this is a very simple flow. There may be a loop over here, there may be various tools over here, but this is a simple representation of what is happening behind the scenes, right? So to get a better clarity of what is happening behind the scenes, let's actually look at a bit of code that we used to create this small agent, right? So I'm going to start a bit of coding. Over here, we are going to use the common platforms. We are going to use LangChain. We are going to use OpenAI. I am using an OpenAI API key as well as an Alpha Vantage key as well. So coming to LangChain, LangChain has a lot of pre-built tools out there. I'm actually going to use the very first one over there, the Alpha Vantage one, which helps us get the historical stock price data. But as you can see, now there are many developers adding a lot of tools over here. We have AWS Lambda, we have DuckDuckGo Search. Google has a bunch of tools available, Google Finance, Google Imagine, Wikipedia is also here. So there are a lot of tools which are being built by community, which make it easy for developers to access some of them and build further upon them, right? So these are tools which help us fetch the relevant data. Wikipedia is also here, Yahoo Finance is also here. And we are going to use, let's say, Alpha Vantage to showcase this particular query. To get the key of Alpha Vantage is quite easy. You can get the free API key over here. The only concern is that it only gives 25 requests per day, right? So that's how you are limited, but otherwise it's free to get the key. Okay, so what I'm going to do is I'm going to use LangChain community to import Alpha Vantage wrapper. And I'm going to access my OpenAI key as well as my Alpha Vantage key using this piece of code. So the API for Alpha Vantage works as expected. If we ask it to get time series, and let's say we are asking it for Apple, by default, it's going to give us the price for the last 100 days, right? So open, high, low, close volume of the last 100 days. Now, what we would want our LLM to understand is, one, what is the stock code? And depending on that, how much data are we really looking for? By default, we are getting 100 days of data. All right, so what we are going to use is, along with LangChain, we are going to leverage function calling by OpenAI. Right? So with function calling, OpenAI sort of helps us in accessing relevant information for functions. It uses JSON format to access the key information over there. And we are going to use a decorator from LangChain called tool to get the relevant information. The key point while defining a function is this docstring, right? So when we are defining this function, we are telling it fetch last 100 days open, high, low, close volume of a stock symbol along with metadata. This is what the LLM is going to really use to fetch relevant information, right? So we create this simple function and we add a few try and except just to create some fail-safe measures. Now OpenAI has a particular format in which it requires functions. So we are going to convert this function into that particular JSON format. And then we are going to call the chat OpenAI API. While we are creating this model, we are using the latest GPT-4o model. We are going to bind it to this function that we have created, get stock price, right? So that it knows that this is the function that we need to run. All right. Now, once I give it a common query which has nothing to do with stock price, it gives a very standard reply, right? So like we were talking about the workflow, it does not go and access the tool. It just tells us, okay, hello, how can I assist you today? It's a response to hey there. But when we ask it, what is the price of Microsoft? One, it identifies that yes, it needs to call the function get stock price. Second, it finds the stock symbol for Microsoft, MSFT. If we didn't feed it this information, it learned this information based on the docstring that we provided, right? The docstring mentioned that we are going to provide a stock symbol over here. So it found out the symbol for us, MSFT, and also told us that we need to use this function. That's all it is doing. It's not really calling the function. It's just identifying this is the function that we need to call with this particular argument, right? If we need to get the final output, we can devise a small function. We have devised a route function over here, which will actually tell it, okay, don't just get the arguments and the function that you need to do, actually run the function as well. So we are creating a simple LangChain over here to parse the output and run the function. Okay, let's ask the same question to it again. Our question was again very general, what is the price of Microsoft? But it's again giving us all the 100-day open, high, slow volume, because we have not fed this information back to the LLM and to the prompt to pass it accordingly, right? So that's the issue here. Also, it's not really a chatbot because this is a one-time kind of query. So what I'm going to do is I'm going to, in the interest of time, jump a few pieces of code and directly come to this part. So over here, I've added a couple of more tools for the LLM to play with. One is on searching Wikipedia. The other is a very simple tool to get the current temperature. And now we are going to create a full-fledged chatbot out of what we did earlier, and then prompt it with certain queries, right? So, for example, I think in the first week of August, I may be traveling to Dallas and I would want to know the weather over there. So when it tells us that, okay, given this prompt, one, it is using a tool called get current temperature, and then it's giving me the output, the current temperature in Dallas is so and so degrees Celsius. Second, if I ask it about Joe Biden, let's see, and I'm also asking to summarize it in 100 words. One, it says that, okay, it has used Wikipedia to get this information, and this is a summary in 100 words. 100 words is too much for us. Let's summarize it in 20 words. So now it's more like a chatbot. It knows what has been entered earlier and responds accordingly. And this is our initial query that we ran on the NVIDIA stock price, right? So this is a quick demo of what agents could do. They could access different tools, they could get relevant information for us, and provide us with a lot of context which may not be present in the native format in the LLMs, right? Right, so I have a few applications listed over here. When we generally think about the use cases of agents particularly, we have to think, one, the dynamic nature of the content. Is the data that we are going to work on, will it rely on real-time information? Or will it rely on a context which is very specific to our organization, which is not present with LLM, right? So be it accessing our SQL databases, be it accessing our operations data, inventory data, and that's going to help us, okay, do we really need an agent over here or not, right? And if it's a one-time simple exercise, probably we are better off just using the LLM in its native form. So I have a simple set of scenarios over here, and maybe all of us can go through it and see what would be a better fit for us, a native LLM or an agent, right? So let's think about the first one, delivering personalized content by analyzing customers' browsing, purchase history, and preferences. What do you guys think? An agent or a good old LLM? Agent? So how many for agent? Can we have a show of hands? Right, so absolutely, agent it is, because requires a lot of dynamic content over here. Right, so again, in the interest of time, I'm just going to show you all the answers at once. So yes, this one requires an AI agent. If there's a one-time thing that we just want a quick reply for a business email, LLM would do the job for us. Similarly, if there's a legal document that we need to summarize, it's a one-off activity, LLM would do the work for us. If it's a repeated activity requiring dynamic data, requiring real-time information, that's where the AI agent could really help us, right? So I think there was a question earlier regarding monitoring, right? So, and monitoring the performance of AI agents is very similar to how you monitor the performance of a machine learning model, right? You look at the KPIs, you look at the key factors which are going to probably push your agent to boundaries. So you try for those edge cases, you monitor the performance extensively in-house before you make it live. Even when you make it live, you have to have a feedback mechanism for the users to give back you a feed response that whether it's working fine or not, right? So standard procedures that we follow for LLMs, there are a lot of tools which are being developed for monitoring the performance of LLMs. And yeah, I think this is a field which is going to grow in terms of complexity and ease as well. So that's all I had in terms of AI agent. We wanted to give you a quick demo of how you could build one. As I mentioned, we are a learning platform, and since all of you are here, we would be happy to offer you a discount coupon if you are interested to pursue your journey on LLMs or data science. We are happy to help you. You can scan this code and send a query, and I would be happy to personally reach back to you. So, yes, and with multiple agents, the complexity comes in interaction between the agents, right? So you call a particular agent that relies on another agent. So the complexity is, I mean, with the tools which are available now, it's not very difficult to make multi-agents. The complexity comes in the time taken to get the eventual output, right? But I can share a few pieces of code with you later on maybe. And so with the systems available, now it's quite easy to build multi-agents, and I can share some pieces of code with you for that. So RAG would more rely on the documents that you have on your server, on your basis, right? So you could think of agents as more specific to getting data from the web, using APIs to get external data, dynamic data, real-time data. So that could be a minor difference, but you could create agents with RAG as well, though. Right, so the lines are, I think, merging a little bit. ChatGPT used to have plugins earlier, which were more like agents. Now they have GPT stores, right? So even the definitions that we use, I think nowadays, agents, tools, functions, these are loose definitions at the best, right? So functions are a subset of tools, tools are a subset of agents. Assistants are, let's say, if you have to think about it broadly, assistants are easily maneuvered through prompts, whereas agents rely on external data, but again, then can be maneuvered with
Say
prompts.
that again, what you just said. Agents rely upon what?
So agents are sort of more maneuvered by the data that you get, right? But they can also be changed with prompts. So I don't have an exact answer for you, but the lines are a little blurred over there.